Hi everyone, welcome to the world of inorganic chemistry. Before you take the Unit 2 quiz, please take a few moments to watch this video about the electron configuration. During lecture, you were introduced to this, the electron filling order. You would need to memorize it and then have to draw it out before you can even start your quiz. And that, my friends, was time-consuming. Wouldn't you feel a lot better if you had some extra time left at the end to take a deep breath, double-check your answers, and walk away with a smile on your face? If this is what you desire, we're here to help. We'll teach you how to determine the electron configuration for any element in a matter of seconds just by looking at the periodic table. You won't even have to lift your pencil. Here is a periodic table that we've all seen before. Looks familiar, right? Now here is the same periodic table, but it has been broken into blocks to show you the electron configuration pattern. Here are a few quick steps to a happier you. The general pattern states that you always start at hydrogen, which is the first element on the periodic table in the top left corner, when writing the electron configuration for any element. Then you always move left to right from the topmost period, period 1. At the end of period 1, you turn around and continue moving left to right in period 2. And so on. This slide shows our familiar periodic table from before, but now with the electron configuration pattern added to it. Now that you understand the general pattern of moving left to right, let's go over the sublevels S, P, D, and F. The S sublevel can hold a maximum of 2 electrons. The first 2 columns on the periodic table represent the S sublevel. For example, H to Fr represents S1, Be to Ra, including He, represents S2. The P sublevel can hold a maximum of 6 electrons. The last 6 columns on the periodic table represent the P sublevel. For example, B to Ti represents P1, C to Pb represents P2, N to Bi represents P3, O to Po represents P4, and so on. The D sublevel can hold a maximum of 10 electrons. The middle 10 columns of transition elements on the periodic table represent the D sublevel. For example, Sc to Ac represents D1, Cu to Au represents D9, and so on. F sublevel can hold a maximum of 14 electrons. The 14 columns of inner transition elements on the periodic table represent the F sublevel. For example, Ce to Th represents F1, Eu to Am represents F6, Er to Fm represents F11, and so on. Given the sublevel and its number of electrons, so far you can figure out which group column the element is in. Let's take S1, P4, D9, and F12 for examples. As you can see, the problem is there are many elements in the S1 column, P4 column, D9 column, or the F12 column. Your element resides in a specific energy level or period or row. The element's energy level is represented by periods 1 to 7 for the S block, periods 2 to 6 for the P block, periods 3 to 6 for the D block, and periods 4 to 5 for the F block. The period your element is in will be written before S1 or P4, D9 or F12 in this case. Each sublevel S, P, D, or F increases in energy as it moves down its period or row. The S sublevel starts at energy level 1. The P sublevel starts at energy level 2. The D sublevel starts at energy level 3, even though it looks like it's in row 4. And the F sublevel starts at energy level 4, even though it looks like it's in row 6. Also, once you reach level 6S, the sequence will be 6S2, then 4F14, then 5D10, followed by 6P6. Likewise, once you reach level 7S, the sequence will be 7S2, then 5F14, then 6D10, followed by 7P6. Just make a mental note of 3 things. The D block starts at 3, not 4. The F block starts at 4, not 6. And when needed, the sequence is S, F, D, P, or so far doing perfect. That's it. The rest is a piece of cake. You simply combine the general left to right pattern with the sublevel pattern to get your final answers. Let's go over a few examples. What is the electron configuration of He? First, let's locate it on the periodic table. You always start from H, which is 1s1. Helium happens to be in energy level 1, sublevel S, with 2 electrons. So your answer is 1s2. What is the electron configuration of O? Once again, let's locate it on the periodic table. You always start from H, 1s, 2. The first period is complete, so the general pattern says to turn around and go to the next period. 2s, 2. 2p, 4. We stop at O, so the answer is 1s2, 2s2, 2p4. What is the electron configuration of Mg? Again, let's locate it on the periodic table. Always start from H. 1s, 2. The first period's complete. 2s, 2. 2p, 6. 3s, 2. And you stop at Mg. So your answer will be 1s2, 2s2, 2p6, 3s2. What is the electron configuration of Ni? Located on the periodic table. Always start from H. 1s, 2. First period complete. 2s, 2. 2p, 6. Second period complete. 3s, 2. 3p, 6. Third period complete. 4s, 2. 3d, 8. Note, the D sublevel's principal energy level starts at 3, not 4, and then you stop at Ni. So your answer is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Lastly, what is the electron configuration of Au? Once again, let's locate it on the periodic table, and you always start from H. 1s, 2. 2s, 2, 2p, 6, 3s, 2, 3p, 6, 4s, 2, 3d, 10, 4p, 6, 5s, 2, 4d, 10, 5p, 6, 6s, 2, 4f, 14, 5d, 9. Note the F sublevel's principal energy level starts at 4, not 6. Also, the F sublevel comes after 6s and before 5d. Remember the sequence SFDP. Stop at AU. Your answer: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d9. Ta-da! All done! Just remember, the pattern takes a very small effort to get used to, but once you understand the general flow, this technique will save you so much time on your quiz and the midterm exam. We wish you the best and have a great semester, guys. Thank you.